applet. So something that we're going to be learning about is work by a mathematician named Feigenbaum, and he was looking at universal aspects of this period doubling. He was specifically studying period doubling in maps with one peak, and that led to a lot of predictions actually. And so the logistic map has been our first example of a map with one peak, but we'd also looked in class the other day at the quadratic map, and its orbit diagram looks like this. And so you can see that its orbit diagram is a bit different than the logistic one. It's facing a different direction, the parameter is decreasing, but at the same time, there's many qualitative similarities between the quadratic map orbit diagram and the logistic map orbit diagram. And as we'll find soon, there's actually quantitative similarities as well. So looking at these similarities, we can see that we still start with this period doubling cascade that produces a bit of a fig tree in the diagram, 1 to 2 to 4 to 8, etc., all happening very quickly, going to windows of chaos, and we can also see that really distinctive period 3 window showing up. Let's take a look at another map that has a single peak, and that's a cubic map with a single hump. And we can see many of the same characteristics again, one solution to 2 to 4 through this period doubling cascade. The period 3 window is not super visible, but it's in there, and there's qualitative similarities, and it will turn out quantitative ones, between this map and our logistic orbit diagram, or this diagram. Let's head to a sine function, actually. So a sine function is not a polynomial, it's a transcendental function, and we are getting really similar behavior, and that means that the behavior is not coming from some kind of quadratic or cubic component, but is coming just from something more universal about the shape of these one-peaked maps. So we have our fig tree diagram again, and we have our period 3 window.